The diaphragm is a dome-shaped sheet of skeletal muscle that divides the thoracic cavity from the abdominal cavity. That may sound simple, but in fact the diaphragm is so much more than just a sheet of muscle. In fact, every breath you take is thanks to your diaphragm. Okay, so let's begin by looking at the general structure of the diaphragm. It curves superiorly into right and left domes. It has a mobile central portion known as the central tendon and a peripheral muscular portion that is fixed to the bones, cartilages, and ligaments of the thoracic cage. The periphery of the diaphragm can be divided into three parts depending on its specific attachment points. The sternal part attaches to the posterior aspect of the xiphoid process. The costal part attaches to the internal surfaces of the 7th to the 12th ribs and their costal cartilages, while the lumbar part attaches to the medial and lateral arcuate ligaments, the L1 to L3 vertebral bodies, and the intervertebral discs in between. Now, the diaphragm is the chief muscle for inspiration, meaning that when it contracts, it helps us breathe in. During contraction, the central portion of the diaphragm depresses, increasing the volume of the thoracic cavity, which in turn increases the volume in the lungs. This makes the intrapulmonary pressure fall below the atmospheric pressure, creating a partial vacuum that allows fresh air to be sucked in. On the other hand, expiration is largely passive, meaning the diaphragm relaxes and rises, which decreases the volume of the thoracic cavity and subsequently increases the intrapulmonary pressure to be above the atmospheric pressure, forcing the air in the lungs to be expelled out. The diaphragm also helps with circulation. During contraction, the increased intra-abdominal pressure and decreased intrathoracic pressure helps venous return of blood towards the heart through the inferior vena cava. In order to properly perform its functions, the diaphragm is attached to surrounding structures by various ligaments and muscular crura. First up, the medial and lateral arcuate ligaments. The medial arcuate ligament is a thickening of fascia that covers the psoas major muscle, which then attaches to the lumbar vertebral bodies and the transverse process of L1, whereas the lateral arcuate ligament covers the quadratus lumborum muscles and attaches from the transverse process of L1 to the 12th rib. Next are the crura, which are musculotendinous bands that attach to the anterior portion of the vertebral bodies. The right crus is larger and longer, and it typically arises from the L1 to L3 vertebrae, while the shorter left crus typically arises from the L1 to L2 vertebrae. Lastly, the fibrous median arcuate ligament is formed where the right and left crura join in the midline approximately at the level of the T12 vertebra. The diaphragm also has three major apertures, which give passage to the structures running between the thoracic and the abdominal cavities. These include the caval opening, which is located in the central tendon of the diaphragm, slightly to the right of the median plane. The caval opening is located at the level of the T8 vertebra. It serves as a passageway for the inferior vena cava, plus the terminal branches of the right phrenic nerve. Next is the esophageal hiatus, which is located in the right crus of the diaphragm at the level of the T10 vertebra. The esophageal hiatus transmits the esophagus, the esophageal branches of the left gastric vessels, and both the anterior and posterior vagal trunks. The third major opening is the aortic hiatus, which is actually posterior to the diaphragm, located at the level of the T12 vertebra. It is located between the left and right crura, posterior to the median arcuate ligament. The aortic hiatus allows passage for the descending aorta, the azygous and hemiazygous veins, and the thoracic duct. Alright, now for a quick break. Can you recall the diaphragmatic apertures at the level of T8, T10, and T12? Now, let's talk about blood supply. The superior surface of the diaphragm is supplied by the pericardiac phrenic artery and musculophrenic artery, which are branches of the internal thoracic artery, and the superior phrenic arteries, which are branches of the thoracic aorta just superior to the aortic hiatus. Its inferior surface is supplied by the inferior phrenic arteries, which arise from the abdominal aorta. Venous drainage of the superior surface is ensured by the musculophrenic veins, and pericardiac phrenic veins, which empty into the internal thoracic veins, and the superior phrenic vein, which empties into the inferior vena cava. Intuitively, the inferior surface of the diaphragm is drained by the right and left inferior phrenic veins. The motor innervation of the diaphragm comes entirely from the right and left phrenic nerves, which originate from the anterior rami of the C3 to C5 spinal nerves. Remember this rhyme: C3, 4, 5, keep the diaphragm alive. Sensory innervation for the central part of the diaphragm is also ensured by the phrenic nerves, while the peripheral part is innervated by the T5 to T11 intercostal nerves and subcostal nerves. The lymphatic drainage of the superior surface of the diaphragm is to the anterior diaphragmatic lymph nodes and posterior diaphragmatic lymph nodes, which then drain into the peristernal, posterior mediastinal, and phrenic lymph nodes. The lymphatic drainage of the inferior surface of the diaphragm is to the anterior diaphragmatic, phrenic, and superior lumbar lymph nodes. Alright, as a quick recap. The diaphragm is a dome-shaped skeletal muscle found between the thoracic and the abdominal cavities, which serves as the chief muscle of inspiration. It also allows passage of important structures between the thorax and the abdomen through its three apertures, which are the caval opening, the esophageal hiatus, and the aortic hiatus. Its superior surface is supplied by the superior phrenic arteries, which are branches of the thoracic aorta, and the pericardiac phrenic and musculophrenic arteries, which are branches of the internal thoracic artery. The inferior surface of the diaphragm receives blood supply from the inferior phrenic arteries, which are branches of the abdominal aorta. Venous drainage of the superior surface is ensured by the musculophrenic and pericardiac phrenic veins, which empty into the internal thoracic veins, and the superior phrenic vein that empties into the inferior vena cava. Venous drainage of the inferior surface is ensured by the right and left inferior phrenic veins. Finally, its motor innervation is provided by the right and left phrenic nerves.